Hello, this is Mr. Collier, and today we're going to be graphing some exponential functions. So in these couple of examples here, we're going to graph, well, the first one's kind of easy because it's 2 to the power of x plus 1. So we know what actually I'm going to draw the graph of y equals 2 to the power of x first, also called the parent function, because it's the most basic exponential function you can get. It looks like this. The y-intercept is 1 because 2 to the power of 0 is 1, and then you have half over here, a quarter, an eighth, and so on. 2 to the power of 1 is 2, and then we have 4, and then the graph looks like this. Okay, so that's y equals 2 to the power of x. I'm going to use red for 2 to the power of x plus 1. What happens is all the y values are increased by 1. So what you could do is you could just take all those points on y equals 2 to the power of x and just add 1 to them, and everything's going to increase by 1, and we have a new horizontal asymptote at y equals 1. So I'm going to draw that in here. That's y equals 2 to the power of x plus 1. And next we're going to answer the part A, B, and C questions right here. So A says, what's the equation of the horizontal asymptote? So the horizontal asymptote this time is going to be y equals 1. And part B, the y-intercept, well, the y-intercept is normally at 0, 1, but we moved everything up 1, so the y-intercept's at 0, 2 for this one. And the x-intercept is, well, actually there's no x-intercept because the function never gets below 1. Okay, so we're going to do the last one here now. Y equals 2 minus 2 to the power of x, and actually you can write this as negative 2 to the power of x plus 2. So let's handle the negative part first. The negative part makes all the values of y equals 2 to the power of x the opposite, or the negative value of y. So like here we have y equals 1 on y equals negative 2 to the power of x. It would be down here at negative 1. Actually, let's graph that first. Let's graph the function y equals negative 2 to the power of x, and then we'll handle the plus 2 part. So in black I'm going to do that. So all the y values are going to be basically reflected over the x-axis because they're now going to be negative. Alright, so the graph is going to look like that. It's just a reflection of y equals 2 to the power of x. Alright, so that's y equals negative 2 to the power of x right there. So when we graph y equals negative 2 to the power of x plus 2, that means we're going to add 2 to all these points here on this black curve right here. So this is y-intercept is 0, negative 1. We're going to add 2 is actually going to be right here. We add 2 here, okay, and we add 2 to this one. So it's going to look very similar, and it's going to look like that. This asymptote is now going to be up here. So the green curve is going to look like this. That's y equals negative 2 to the power of x plus 2. And the equation of the horizontal asymptote is going to be y equals 2. It's just equal to this number right here. The y-intercept is 0, 1. And see the x-intercept, well, there is x-intercept this time. It's right here. That's 1, 0 is the x-intercept. Or you can say y equals 1 is the y-intercept, x equals 1 is the x-intercept. Okay, let's take a look at another example. Here we have 2 to the power of negative x plus 3. So I'm going to graph actually y equals 2 to the power of negative x first, and then we'll add the 3. Alright, so if y equals 2 to the power of negative x, if you have a negative x, that basically means you have a reflection in the y-axis. And the reason is, first of all, let's look at some values. 2 to the power of negative 0 will be 2 to the power of 0. You'll have the y-intercept right here. But when we go over to 1, we'll have 2 to the power of negative 1, which equals half. So it's going to look like this, then a quarter, then an eighth. But if we put in x equals negative 1, 2 to the power of negative 1 is the same as 2 to the power of 1, so it's like this. It's just like y equals 2 to the power of x, except it's reflected in the y-axis. So that's y equals 2 to the power of negative x. Then we're going to add that 3. So all points go up 3. 1, 1, 2, 3. So there's a new y-intercept. This is at half, so 1, 2, 3. So the new asymptote is going to be at y equals 3. And this point goes up 1, 2, 3, and it looks like this. Yes, y equals 2 to the power of negative x plus 3. And I guess now we can answer these questions actually. So part A was equation of the horizontal asymptote, so that's going to be y equals 3, same as this number. Okay, the coordinates of the y-intercept and x-intercept. So the y-intercept here is 0, 4, and there's no x-intercept. Okay, so next graph here we're going to look at this function, which we can rename negative 2 to the power of negative x plus 3. So I'm going to graph actually y equals negative 2 to the power of negative x first. So you see the blue function here is y equals 2 to the power of negative x. So we already have that graph there. We're just going to reflect it now on the x-axis, right? All these values will become, all the y values will become negative from the blue one. So that was half, so now it's going to be negative half and so forth. That was the y-intercept 0, 1, so now it's down here at 0, negative 1. All the points are down here. So it's a reflection in the y-axis. There's y equals negative 2 to the power of negative x. But we want negative 2 to the power of negative x plus 3, so move all these points up 3. 1, 2, 3, and this one's going to be 1, 2, 3, 1, 2, 3, 1, 2, 3. Alright, so it's going to have a new asymptote up here. Y equals negative 2 to the power of negative x plus 3. And the asymptote is going to be y equals 3. The y-intercept is 0, 2, and the x-intercept, we do have one. Now, that's going to be kind of tricky to find, but actually, if we want to find the x-intercept, we just let y equals 0. So I'm going to get the y-intercept now. So this function is, for the y-intercept, we're going to let x-intercept, we're going to let y equals 0. So 0 equals 3 minus 2 to the power of negative x. I could add 2 to the power of negative x to both sides. I get 2 to the power of negative x equals 3. Actually, let's forget. Let's do it. Use our graphing calculator to solve this. So what I'm going to do is graph this on the graphing calculator and find the x-intercept that way. So I'm going to quit here. I'm going to go to y equals, and I'm going to type in 3 minus 2 to the power of negative, make sure you use a negative sign, not the minus sign, negative x. Okay, and if you see something like this, like plot 1 is highlighted, you should go and unhighlight that so it doesn't plot a bunch of points in your stats mode. So I've got that done. I'm going to grab, actually I'm going to zoom 6 to do zoom standard. And there's the graph, and I want to find the x-intercept, so I'm going to go second function, calc, and we're finding the 0 is the x-intercept, so I'm going to find that. Left bound, I need to go to the left of the x-intercept, and then I'll go to the right of the x-intercept, try to guess what the x-intercept is. And the x-intercept is actually negative 1.58. So we're going to type that in now. Negative 1.580 is the x-intercept. Let's take a look at some more examples here. So we have graphs here, and we have to figure out the value of c. So if you recall, the value of c is the same as the value of the horizontal asymptote. So in the first equation is the red one. We see that the horizontal asymptote is at 1, so y equals 1 is the horizontal asymptote. And write down the equation of the, oops, sorry, that was supposed to be the answer to part B, and the value of C is going to be 1. Alright, in the next example, again, C is equal to the horizontal asymptote, so you see it's down at -4, so C equals -4, and the horizontal asymptote is Y equals -4. Okay, so this next one, the red graph is number 3. We're going to use the graph to find the value of C. Well, the horizontal asymptote is 0, so C equals 0. Write down the y-intercept as an ordered pair. That means it has a coordinate, so the y-intercept is 1. That's 0, 1. Use the y-intercept and C to find K, so we'll have to do some algebra there. We're going to use the y-intercept. The y-intercept, so I can plug that in. That's 0, 1, so I can plug in 1 for y. That equals K times 2 to the power of 0 at the y-intercept. Plus, we already know C is 0. So I work that out, I get 1 equals, this is 1, so K, that's it. So K equals 1. And write down the equation of the graph. So now we know K and C, so we can write down the equation as y equals 1 times, or we just leave out the 1. So it's just 2 to the power of x plus 0, and that's it. Actually, it's just y equals 2 to the power of x. So the next one, the blue function, we're finding the C value. So the axis of symmetry is at y equals 4. We have to write the y-intercept as an ordered pair. Looks like it's at 3. So that's 0, 3. And then we have to find the C value. So 3 is the y-intercept, so 3 equals K times 2 to the power of 0 plus the C value is 4. So 3 equals, that's just 1, so K plus 4. And subtracting 4, we get K equals -1. So we have K equals -1. And writing the equation now, we have y equals -1 times 3 to the power of x plus 4. Oops. The first one should be C equals 4, yeah. Okay, so there's the equations. Let's take a look at one more example here. So we're looking at the red function here. Use the graph to find the value of C. So again, the horizontal asymptote is at 2, so C equals 2. Write down the y-intercept is 5, so 0, 5. Use that to find K, so we're going to put in 5 equals K times 4 to the power of 0 plus 2. We can subtract 2 from both sides. 3 equals K. So we have that 3 equals K. And the equation is y equals 3 times 4 to the power of x plus 2. And that's it for that one. Okay, next we're going to find the equation of the blue graph, and then maybe I should scroll down a bit. So the value of C, the horizontal asymptote, is at -1, so C equals -1. The y-intercept is -3, so 0, -3. And we're going to solve now to find the value of K. So we have y equals, actually the y value is -3, so -3 equals K times 3 to the power of 0 minus 1. We can add 1 to both sides right now to get rid of that -1. So we have -2 equals, and that's just 1, so -2 equals K. K equals -2, and the equation of the exponential function is y equals -2 times 3 to the power of x minus 1.